Hello everybody, it's Mr. Kim. In this video, you'll be able to see how the Chapter 5 review packet is done from number 1 all the way down to I believe it was number 19, yes? So we have all the things that we need from this packet, starting with Venn diagrams, tree diagrams. There's mutually exclusive general addition rule for that, and there's also multiplication rule for independence, checking for independence. I believe it's not really coming up in these because they give you just a lot of probability questions, but we all know how to check for independence, and I'll also provide you a separate video representing how to deal with independence in those regards. Without any further ado, let's get started for the question. So in the fall of her senior year in high school, Carrie has begun to submit her college applications. So her admitted to University of Georgia is 0.45. Admitted to both the University of Georgia and Auburn University is at 0.25. So my immediate attention first focus on this number right here. So here's my Venn diagram with the rectangle around it. So 0.25 will stay in the middle. And so we have Georgia and we have Auburn. And it seems like the probability of her not being admitted to both is 0.10. So that's a 5, by the way, in the middle. If the Georgia is 0.45, it means that this portion right here has to be 0.45, that blue circle entirely. So that means that I need to have 0.2 left over. 0.2 plus 0.25 gives you 0.45 in total. And the only thing that's really left to do is to figure out this number in Auburn. Remember, a valid probability model always states that all of these four numbers, the 0.20, the 0.25, the 0.10, as well as this number, which we don't know at the moment, they need to add up to 100%, or in decimal, it will be 1.00. So when you add all those numbers together, I believe you get 0.55. So then the rest of those numbers will be 0.45 here. And when you take a look at Auburn, it's not only the people who just go to Auburn, but also to both getting accepted to Georgia as well. So when you add these two numbers together, that should be 70%. That should be the correct answer. The grade level breakdown at Bryan School, freshmen, sophomore, juniors, and seniors. Now, if you take a look at this type of context of the question, this is obviously a mutually exclusive event. You can't be a freshman and sophomore at the same time. Same goes with juniors and seniors. So if we're talking about either junior or senior, we can just do probability of A plus probability of B. In other words, that will be probability of juniors plus probability of seniors. And yes, you can subtract the overlap, but there is no overlap because you can't be juniors and seniors at the same time. So adding these two up will give you 41% in total. 3 is the only question I saw with independence, and this one probably is one of the harder multiple choice questions. My advice for this is to always draw a Venn diagram and see what happens. Here it says P of not A and not B is 42%. So the biggest problem that a lot of students have is to understand what this is about. The 0.42 represents the rectangle, basically. It's the part of the it's not the part of the Venn diagram, if you will. So probability of A and probability of B, we have it respectively as 0.3, 0.4, but our ultimate objective is to figure out what this middle number is first, and then we can figure out the rest. So if you know the valid probability model adds up to 100%, and the non-part of the Venn diagram is 42, that means somehow these two Venn diagram has to add up in total to give you 0.58. Now you know that 0.3 plus 0.4 is way above 0.58, which means minus the overlap should give you the 58%. That's A or B happening, A or B. So if you do the math here, that's 70%, 0.70 minus this overlap gives you 0.58, which means the overlap has to be 12%. So I can fill that up with 0.12 in the middle. That will leave A would be 0.18 because 12 and 18 plus gives you the 30%. 0.12 plus 0.28, this together gives you 40%. Now we have our sample space. We have all the numbers listed. So is this, first of all, disjoint? Disjoint is the same as mutually exclusive. So is this mutually exclusive? Absolutely not. It's it cannot be disjointed because it's not a separate circles, right? So it's not a Venn diagram where they're separated entirely. There is an overlap. Overlap always means that it's going to be non-disjointed. or it's going to be not mutually exclusive. They have a common ground. So now, are they independent or not is the question. So to check for independence, remember, all you really have to do is P of A, is that the same as probability of A given B? Well, probability of A is given to us as 0.3. And what is probability of A given B? That is probability of A and B happening at the same time over probability of B. A and B is the one in the middle of the Venn diagram, which is 0.12, over probability of B, which is 0.4. And you can see that if I were to just kind of cancel this out and simplify it, that will give you 3 over 10, which is 30%. So that checks. Is that really good enough? What if we do it the other way around? Probably B given A. So 0.4 is equal to the same 0.12 over probability of A now, which is 0.3. And you can see how they give you the exact same thing either way, whether you do it A given B or B given A. So yes, they will be independent. So the answer will be D. Each Saturday morning, I don't even know how to pronounce his name, but throwing pitches to his dad. His dad estimates the probability of each pitch being a strike is 0.6. So the first one being a strike is 0.6. The second one being a strike is 0.6, and so on. Every pitch are independent from one another. They really don't impact the chances of it being a strike or not on the second or third attempts. And we're talking about, so they tell you that each attempt or each pitch is independent. What is the probability that neither of Bo's next two pitches will be strikes? Which means we're trying to figure out the chances that it's not a strike. So if this is a chance of being a strike, the chance of not being a strike is the opposite from 1. You can do 1 minus 0.6, which gives you 0.4. So the first one not being a strike is 0.4. The second one not being a strike is also 0.4. The general rule of multiplication says that as long as they're independent events, you can multiply those two together, 0.16, and voila, we have the answer here. And let's move on to 5 to 7. This is very similar to the one tree diagram question I gave you during class. 8% of the patients in a small town are known to have the heart disease. So first, I'm going to have heart disease and no heart disease, 0.08 and 0.92. And suppose a test is available that is positive in 96% of the patients with heart disease. So it's 0.96 positive, 0.04 negative, and then it's going to have 7% of the patients who do not have a heart disease, but they're going to show a false positive, minus and then 0.93. And so remember what I told you, that it's very ideal for us to have those four numbers right away. So I'm going to use my calculator on the side here, and then 0.08 times 0.96, that's 0.0768. It looks like, okay, there we go. So 0.04 times 0.08, okay, 0.0032. 0.92 times 0.07, that's 0.0644. 0.92 times 0.93, 0.8556. Okay, so you're going to use your calculator and get all these wonderful numbers. And now you're going to go to the questions, right? So what is the probability that a person has a heart disease and tests positive? So has a heart disease and tests positive means you go to the heart disease people and also test positive. Well, that's 0.0768. We have that listed. What is the probability that a person tests positive for the heart disease? Well, that's this plus this, which is 0.0644 plus 0.0768, which I believe should give you 0.1412. So that should be the answer right there. Just have to add these two up, right? Because those are the ones that tested positive. If a person is out there random and given a test and comes out positive, comma. So they should use the word given for this. So it says if a person is selected at random that comes out positive, same thing as saying given that a person is tested positive, comma. So the probability is out of this number that we found from part question 6. What is the probability that the person actually has the heart disease? Well, that's 0.0768. So it's literally question 5 over question 6. I believe when you do that, you should get about half. So I think the answer should be E, but just to verify, 0.0768 divided by 0.1412. Okay, so you can see how I get the answer as 0.5439, which is answer choice E, or number 7. All right, so moving on, 8 through 10. So we have a two-way table. What is the probability that one randomly selected student made a B, given that he was not enrolled in a science class? Not enrolled in a science class means 10,000 minus 1,600, so it would be these two combined together. Out of 8,400 people, how many students made B? Well, that's this plus this, right? So you can do the same thing using the calculator here. 1890 plus 630. So that's 2,520 out of 8,400 should give you exactly 30%, I think, in total here. And to check the answer for number 8, yep, I got D, and the answer key is also D. What is the probability that one randomly selected student was in history and made A? So was in history and made A means you just have to kind of circle the A's, circle the history, and there's my overlap because we're talking about and. So that's 882 out of the total 10,000. Let's use the calculator one more time, or do I even need to? Because it seems like A seems like the clear choice here. 882 over 10,000. Yep, so I was right. So it's just A dividing by 10,000, moving the decimal point left 4 times. What is the probability that one randomly selected student made an A or was in math class? So probability that the student made A plus probability student was in math class minus probability student of A and math. Remember that you add the two probabilities up, subtract the overlap, and then you should be able to get the correct answer. So made A is 3,392. Math is 6,300 minus the overlap, 2,142. And that should be out of the total, which is 10,000. So let's put these all numbers together. And with the plus, 3,392 plus 6,300, which I believe is the right one. Yes. Minus 2,142 divided by 10,000. And voila, we have D as our final answer. So the answer for number 10, yep, it should be D. All right, so halfway there, let's finish this through. Many fire station handle emergency calls for medical assistance, and that for incoming call is for medical assistance 0.85. I hope it goes without saying that the probability that it's not happening is 1 minus the probability of it actually happening. That's always the rule for complements, right? Probably A given A is A complement is always 1 minus the probability of A. Assuming independence, calculate the probability that exactly one of the next two calls will be for medical assistance. So assuming independence, exactly one of the next two calls, my advice is to draw a tree diagram for this because the first call being a medical assistance, so medical assistance or not medical assistance, that will be 0.85 this way, 0.15 that way. Now there's another call which means it will be M complement, and all the chances will be the same because they're independent, right? The one's event doesn't influence the call of the second being a medical assistance or not. So it being exactly one of the next two calls being for medical assistance means this branch right here, because you need to have one medical and one non-medical reason. There is one medical here. Oh, that's not the right one. One medical and one non-medical reason there. This means that neither of those two calls were for medical reasons, and this means that both calls were for medical reasons, which means that I can't include these two. It's got to be these two here. And you can see that the general rule of multiplication says that I can just multiply those two probabilities together. So if I do 0.85 times 0.15, what I'm going to get is 0.1275 for both because they give you the same probabilities, 0.85 times 0.15. So I add that with 0.275 or just double it, whichever you prefer. The answer should be B for that reason. 13. I toss a penny and observe whether it lands heads up or tails up. Suppose the penny is fair. So fair means a fair chance, and you're roughly estimating about half of it to be heads or tails. That every occurrence of head must be balanced by a tail in one of the next 2 or 3 tosses. Now, A cannot be true because we are talking about chances. What if it happens in the next 4 tosses, 5 tosses? You could have consecutive heads flipped multiple times, more than twice or 3 times, because it's all done by chance. This is not a guarantee. You can't use the word must in a probability. It's never a guarantee that that's going to happen. That if I flip the coin many, many times, the proportion of heads will be approximately 1/2, and this proportion will tend to get closer and closer to 1/2 as the number of tosses increases. Now, this sounds like the law of large numbers, or I like to call it rule of large counts. I'm just going to call it LC. We talked about this in the first day when we talked about chapter 5. And so that literally, like, look at the longevity of this answer choice. It sounds the most ideal, but I will go through C, D, and E just to make sure everything else is not the correct answer. That regardless of the number of flips, half will be heads and half will be tails. Very bluntly put, and you're guaranteeing that half will be heads and half will be tails. Somewhere you should say that this is not a guarantee. Same thing, same reason for A. C doesn't sound right. It's not a guarantee that half will be heads, half will be tails. It's going to be approximately. These cushioning words should be there to make it sound okay. But will be, like will be this, will be that. Can't say it in statistics. Generally, the flips will alternate between heads and tails. So you're going to get heads, tails, heads, tails, heads, tails. You're not going to get multiple of heads in a row. Not true. About half of the number of tosses would be heads. E is like a condensed version of B. About half. So there's a cushioning word about, but B is the better choice between the two. And you guys can probably see that when you read this answer on your own. Okay, so let's keep going here, and we are looking at number 14. What is the probability that an airline has fewer than 3 delays? These represents the days, number of days that were delayed. If it's fewer than 3, that means you're really just taking a look at these guys. It's 0, 1, or 2. So add up the probabilities, and you should be able to get, I think it's 85. So answer choice is D. Moving on. Same thing. Shoe size of more than 7 means these two, so that should be 30%, which is E. That was easy. Approximately 30% of the calls to an airline reservation phone line result in a reservation being made. Suppose that an operator handles 10 calls. What is the probability that none of the 10 results in a reservation? So the first one, not being a reservation, is 0.7, because 30% is for the reservation, and then that means that the rest, 0.7, will be not reservation. But you're doing this 10 times, and all of those calls, like none of those calls are for reservation, means all of those calls will be for non-reservations. So imagine you do this. Every single part says 70% for chances. Remember, they're all independent events, so you're just going to multiply all of these. Now, who has the time to sit there and type all of these in? 0.7 raised to the 10th power, yes? Answer is 0.02824, or you can write it to 0.02825. If you're wondering about the decimal points, my recommendation is always to write down quite possibly about 4 significant digits, those of you guys in physics. Excluding the 0, how many numbers you actually see. 4 significant digits should be good. So 0.02825 is also another acceptable answer for this. What assumptions did you make in order to calculate probability in A that they are independent? Sorry, I don't feel like writing the whole thing out, but we are assuming you want to write down, we are assuming that each of the calls made are independent from one another, so we can multiply the probabilities together, all that good stuff. Sentences, please, not just bluntly putting independent as one singular word for your answer. What is the probability that at least one call results in a reservation being made? At least one call means out of the 10 calls, 1 call was made, 2 calls were made, 3 calls were made, and so on. 10 out of 10, all calls were made for reservations. Which means, if you think about the valid probability model, none of the calls out of the 10 being made for reservation, all of these constitutes of 100% of the total possible events that are there. We have found this from part A, 0.02825. At least one reservation being made are all of these events. So what do you think I'm going to do? Take the 100%, subtract this away, and you got the rest all added up together. Because you're not going to find these individually, 1 call made, 2 calls made. That's a lot of work to do. So 1 minus 0.02825, that's 0.97, 175, I believe. So we're 0.972. So 97.2% should be the correct answer. Any of these three would do. All right, 17. Make a Venn diagram. Same university question as I think number 1 that we just did. So make a Venn diagram. So I'll draw these really nice circles here. And then we have both will emitter 0.2. We have Harvard, we have Florida. You guys know the idea. So Harvard here should be 0.2. Florida should be here 0.3. And then the rectangle around it should consist about 0.3 here as well. What is the probability that neither? That's the answer. What is the probability that she gets into Florida, but not Harvard? That is this right here. Because those are the Florida people or Florida's acceptance rate, but Harvard has nothing to do with that. So that's 0.3. A company has 7 mathematicians on its staff, 2 of whom are women. So 2 out of 7. The president of the company is concerned about the small number of women mathematicians. The president learns about 40% of the mathematicians in the United States are women and actually investigate whether or not the number of women mathematicians in the company is consistent with the national pool. So the way that we use random number digits is that like you can use it kind of in a very flexible manner, but we have 40% as our national pool, which means if we have the digits from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, which are 10 numbers, why don't we assign the first 4 to be female and the last 6 to be male? And then we literally physically count how many zeros, ones, twos, and threes that we see. Now, what are all of these random numbers for? Well, it's basically for you to use, and it doesn't matter as to how you use this as long as you follow some sort of a chronological way. So you read from left to right. Here's how I did it. You want to pick a group of 7s because the company has 7 people in its staff. So you circle every pairs of 7. I know there's like a space in between every 5 digits there, but you can just kind of ignore that and then just group them all together, and that's 7 digits there. And this is also 7 digits. That right there is 7. That's 7. And that should be 7 right there. I think it says to use the simulation 5 times. So that's 1, 2, 3, 4, 5, 7 digits I have as our trials. Now let's find out how many 1s, 2s, and 3s and 0s that we see. It seems like for this first group, I have only 1, 2, so that's 1 woman. 2 and 1, that's 2. 3, that's 1. 1, 1, and 2, that's 3. 3 and 0, that's 2. So if I were to average all of these numbers up, that's 4, 7, 9, 9 over 5, which gives me about 1.8 women per 7 company people that we have. So out of 7 people that we choose, about 1.8 of them should be women. And this company has 2. Is it consistent with the data that we had from the beginning? Yes. 40% we claim we did the random number samples, and then we picked out how many women there were. And it seems like the company is not discriminating against women whatsoever because the statistics and the math proves it. This is what the conclusion you would say, basically. We are down to our last question. And so find the probability that a student graduates given that he participates in sports. It seems like a tree diagram question again, and look at that. Lo and behold, they actually ask you to draw the tree diagram. But let's do part A and B together. First, before we do C. Graduates, given that he participates in sports, which means a 0.2 should be your denominator number. If I were to do this in a more technical way, we're trying to find out, given that the student plays sports, find the student that graduates. That would be probability of G and S happening over probability of S. We have 0.2. Participates in sports and graduates, which would be that. That would be 0.18. Your answer for part A for 19 should be 0.9, therefore. Find the probability that the individual does not graduate, given that he participates in sports. So does not graduate given that he participates in sports. So that means it's still going to be out of 0.2 because the probability of S, of course. But what's the chance of not graduating and playing sports at the same time? Well, if you think about it, 20% play sports, okay? And 18% does both graduating and playing sports. So how much are left here if the entire sports is 0.2? Probably guess it, it's about 2%. So what that means is the 2%, these people right here are the people who play sports but has nothing to do with graduation. So what you can do is put 0.02. This represents probability of G complement, not graduating, and playing sports at the same time. That's that portion right there. Over probability of obviously S, 0.1. These two should add up. Part A and part B should add up to back up to 100%, in which it does, so everything's fine. Draw the tree diagram. So first, let me do sports, not sports. So I think sports is 0.2, that's 0.8. Graduating and not graduating, we have those numbers actually from here. So this is why it's confusing, but you need to write 0.9 and 0.1. Remember that each of those branches and each of those events has to add up to 100. And when you actually take these two numbers and multiply them, that becomes 0.18, which represents this right here. That's the people who play sports and graduate at the same time. Then you do 0.2 times 0.1, which gives you 0.02. That basically is probability of GCNS, probability of GNS. So we have those two. Now it's our job to figure out the rest, graduating and not graduating. The student graduates given no participation in sports, which means given that the no participation sports is given, then the student graduates. That's representing this portion right there, I believe. And that is 82%. So what that means for us is that the student graduates given that the student does not play sports. It's already given to us. So we can write 0.82 here, 0.18 there, and then when you multiply all those numbers together, let's use the calculator for this actually. 0.82 times 0.8, which is 0.656, 0.18 times 0.8, which gives you 0.144. And you can see how all of these numbers combine to give you 100% again. And these two also adds to give you 80% from the beginning. Now, why did I put 0.82 here and not here? Well, first of all, if you decided to put 0.82 out here, then these three already exceeds 1. So you should know that that is not the right course of action to take. So then how do I know that 0.82 belongs here? Well, that's graduating and also not playing sports at the same time. I know it says given, but this means that probability of G and SC happening over probability of SC happening. So given that it's not playing sports, that would be X, because I still don't know that. Graduating and not playing sports, this actually, the conditional probability actually equals 0.82. And when you try to solve for X, when you try to do the algebra in this section, you have to multiply both sides by 0.8 like this to cancel this out, which in turn, this makes this number, the probability of G and not playing sports. And this is probability of not graduating and not playing sports at the same time. So that's my tree diagram, and find the probability that the individual does not participate in sports given that he graduates. It's this. So that will be probability of G, probability of SC and G. That would be this one. So that would be 0.656 over the people that graduate are this number and this number together. So 0.656 plus 0.18 together. And you can use a calculator for this. 656 divided by 0.656 plus 0.18. Okay, so that should give you 0.7846 or 0.785. That should be the probability. Okay, so I hope this helped in understanding the materials. And if you guys have any further questions, please let me know. And I'll see you guys on Monday.